In this video I want to focus on the calculations you'll do for this density characteristic property lab. And you've already got all this data that you would have collected here. I'm just going to show you some samples here on how to manipulate this data and how to get the density from the data that you've already gotten from the lab. So assuming you've done all this, you can now calculate the density of each sample that you have collected. Now what you'll be able to see here is that we did get a mass of the empty 50 ml graduated cylinder, and it was 75.000 grams. And we got a mass of the graduated cylinder containing 10 mils of water. Now the density per what's in the background, and I would recommend you read the background so you can make sure you understand what density is and how we get it. But per that discussion, density is mass divided by volume. Mass of what? The mass of the water divided by the volume of the water. I'm actually going to be a little bit more clear with that. So density is mass of water divided by volume of water. So the masses we have is actually not the mass of water. How could we get that? How do we get the mass of water? Well, we can get the mass of water by subtracting the mass of the empty graduated cylinder from the graduated cylinder containing the water. So it's not really too bad, is it? So 85.00 grams minus 75.00 grams. Now you need to be a little bit careful here. When you do the actual calculation, you'll see that if you put in a calculator, it'll come out to be 10, but it's going to maintain the same number of decimal places as we started with. So you need to add the grams in at the end here as well. Let me make sure I put that on the line here. Let me enlarge that a little bit. There we go. So you see that's 10.000 grams. So it is important to keep the same decimal places here as what you started with, as we still have the same kind of precision in this measurement as we had in these figures right here. The volume we've already got. We've got 10.0 mils. We read that directly off the graduated cylinder. So now we can go ahead and calculate the density, and the density is going to be calculated by the mass, which is 10.000 grams, that's just the mass of the water, divided by 10.0 mils. The result of that is going to be 1.00 grams per mil. Let me talk first of all about the unit. The unit here is mass divided by volume. So if this is grams, this is mils, we end up with grams / mils or grams per mil. And that's important. I mean, that's going to be the unit that we'll be using. The other thing here is the number of significant figures that we see for the density measurement itself. The way I get that, this actually has 5 significant figures. 1, 2, 3, 4, 5. It's got 3 decimal places, but 5 significant figures. And this one actually has 3 significant figures. 1, 2, 3. So the answer can be no more accurate than the least accurate number we use to get that answer, which is the volume here. So we end up with 3 significant figures here as well. So that'd be 1.00 grams per mil. Alright, let me show you. You'll just repeat that for all the other data that you'll do. Let's take a look at the solids here. So again, the density of 15 grams of iron here is going to be the density is going to be the mass of iron divided by the volume of iron. Now we can easily get the mass. The mass is going to be obtained by taking the mass of the graduated cylinder that has the water in it and subtracting out subtracting that from the mass of the graduated cylinder with the 20 mils of water and the 15 grams of iron. But again, we have to be careful about the number of significant figures we're using here. So the mass of Fe here, of iron, is going to be 110.000 grams minus 95.000 grams, which is going to equal 15.000 grams. So again, the same thing as we talked about earlier. We need the same precision on the mass as we had in the beginning. So we've got 0, 0, 0. We're going to have 0, 0, 0 here as well. So I know you added 15 grams, but the exact mass you added was actually 15.000 grams. So that's important. We need to keep on going with that. We also need the volume. Now it's the volume of the ion itself. Now if you recall, when you were doing the experiment, you started out with 20.0 mils of water in the graduated cylinder, and then when you added the ion, it went up to 22.0 mils. So the difference there in the volumes must be simply the mass of the volume of ion in that sample. So that would be 22.0 mils minus 20.0 mils, which is 2.0 mils. Again, the same precision is present here. Notice how we've got 0.0 and 0.0, and this comes out to be 0.0 as well. So now we can go ahead and get the density, and the density is going to be mass divided by volume, 15.000 grams, divided by 2.0 mils. Now this is going to come out to be 7.5 grams per mil. So the same unit as we used before when we were calculating the density of a liquid. But looking at the significant figures, we've got 5 up the top here, 1, 2, 3, 4, 5 for the mass. We've only got 2 here on the volume, 1, 2. And that's how we're getting 7.5 grams per mil here for the density of our ion. So that will be repeated again for the iron, the aluminum, and this unknown metal down here. So now you should be able to do those density calculations fairly easily.